Hey guys, this is Mr. Gron and this is 8.4 Rational Functions. In this video we're going to be focusing on the zeros of rational functions. Alright, so to try to learn about how zeros come about in a rational function, we're going to start out with graphing this rational function, and we're going to look at where it crosses, the points where it crosses the x-axis. Those are our zeros. So I've got the graph loaded up over here. Now it's kind of a tall, narrow graph, so it's a little bit different than what you're used to looking at probably. But this is a fairly typical rational function. Sometimes this diagonal part that runs across is more horizontal. There's usually a very vertical portion of the graph, and it's usually split into two or more parts like this. There's sort of a left side and a right side to this. Now, if we kind of zoom in here and we examine first just where the zeros are, where does it cross the y-axis, or the x-axis, excuse me. One of them would be right there, and the x value is at -1. You can kind of see that up at the top of my graph screen. And then the other zero is over here at x equals +3. So those are our two x-intercepts, our two zeros. Well, now I want us to think about how that relates to the actual equation of the graph or the function, and especially the numerator. So if I factor out the numerator, what I'm going to see, hopefully, is that it matches our zeros. So multiplies to -3 but adds to a -2. That's going to be a +1 and a -3. What solves for x plus 1? A -1. What solves for x minus 3? A +3. If I plug either of these numbers into this equation, then the top of the fraction is going to be 0 and the bottom is going to be just some number, right? So essentially what happens with a zero of a rational graph is if you get the top to be 0 and the bottom to just be a number that's not 0, then the height, the output, will be equal to 0. All right, so when it comes to finding zeros, this is our standard definition, right? It's where it crosses the x-axis. That's what a zero is. We can find the zeros by factoring the numerator and setting each factor equal to 0 and solving for x. All right, so I've got a few examples here. What we want to do is factor the top and the bottom if we can. So this one is going to be x plus 6 and x plus 1 over x plus 3. And notice that nothing cancels out here. That's important. If something cancels out, it is not a zero. All right, so our zeros for this one, for number 1, are going to be at -6, 0, right? So it's an xy coordinate. And at -1, 0. Those are two zeros, or two coordinates for our two zeros. All right, for number 2, that's going to be x plus 5 and x minus 3 on top. Multiplies to -15, adds to a +2 over x minus 1. Again, nothing cancels out. And our solution, or our zeros, excuse me, one of them is going to be the point -5, 0 for the x plus 5, and the other one is going to be 3, 0 for the x minus 3. All right, our other one over here, there's nothing to factor on top, so it's probably going to be a +2, but just to be sure, if we factor the bottom, we take out a GCF, we get x minus 2 over x times x plus 1. And I'm just doing that to verify that nothing cancels out. And we'll learn about that in a different video. All right, so our 1, 0 for that one is 2, 0. And then our last one down here, the top is a GCF. I can take an x out, and then it's 3x plus 1. And the denominator is a difference of squares, -3 plus 3. All right, now this is one that oftentimes students don't get. And the factor on the top here, x, if x itself is a factor by itself, that means that 0 is one of the zeros, one of the solutions. So 0, 0, right? Because if I plug 0 into this equation, it's going to be 3 times 0 squared plus 0. It's all zeros on top, right? And the denominator is not 0, and that's good. We want the top to be 0 and the bottom not to be 0. All right, and then for the other one, the 3x plus 1, that one, maybe you need to solve that by doing 3x plus 1 equals 0, and then solving it. So we'll subtract 1 from both sides, get 3x equals -1, and then divide both sides by 3, and we'll get our second 0 is -1/3 0.